This tutorial explains how to test for x-axis symmetry, y-axis symmetry, and origin symmetry. In each case here, you plug in the opposite of what you're really testing for. So for example, x-axis symmetry, you'll see on the screen here that you plug in negative y, or the opposite of y, when you're testing for x-axis symmetry. To test for y-axis symmetry, you plug in the opposite of x. Why you plug in each one of these, for many students, is confusing. For x-axis symmetry, for example, if I just was to make a quick sketch here, and let's suppose that you have the point 2, 5. If I reflect over the x-axis, I would get 2, negative 5. So as a result, you can see here y value went from positive 5 to negative 5. And as a result, that is why we plug in the opposite of y. So let's go through a variety of examples. The first one I have for you is 36x squared plus 4y squared is equal to 9. So let's test for x-axis symmetry. We're going to plug in negative y. So 36x squared plus 4 times the opposite of y squared equals 9. And simplify. Squaring the opposite of y, well, this is like squaring negative 1, which is positive 1, and we now have 4y squared equal to 9. It's the same as the original, so therefore this graph does have reflection over the x-axis. Testing for y, plug in the opposite of x. So 36 times the opposite of x squared plus 4y squared equals 9. And similar to the last one, when you simplify, you get back the original. So this also has y-axis symmetry. And as you might imagine, if you test for the origin and you plug in the opposite of x and the opposite of y, you will see that again, that simplifies into the original. So what does that mean? That means that for this problem, there is symmetry on the x-axis, the y-axis, and the origin. So let's try another one. This time, let's make the equation be x minus y squared equals 10. Again, to test for x-axis, we plug in the opposite of y. So x minus negative y, or opposite of y, squared. So now, the confusing part on this is people immediately look at this and see two negatives, and they've always been taught to chain it to a positive. However, remember that order of operations says to square first. So this right here needs to be done first, squaring the opposite of y. That is y squared. The minus sign comes down, and we have the original. So the x-axis Symmetry is yes. Y-axis symmetry. Opposite of x minus y squared equals 10. That looks close to but not the same as the original, so this one would be a no. And then test origin. Plugging in the opposite of x and the opposite of y. And simplifying. And again, we do not have the original, so therefore this would be a no. Let's try another one. This time, let's write out y equals x squared plus 2 over 5x cubed. Let's test for x-axis. X-axis symmetry, that is. Plugging in the opposite of y, one can quickly see that we do not have the original. So this is immediately no. What about y-axis symmetry? Plugging in the opposite of x. And simplification on this one is a little bit more tricky. This is going to be x squared plus 2. Again, squaring negative 1 results in a positive 1. And in the denominator here, taking negative 1 and cubing it, you get negative 1. So I'm going to write negative 5x cubed. So the y matches up, x squared plus 2, that is the same, but negative 5x cubed, not the same. So this is a no. Let's look at origin. Kind of the confusing part. This time when you plug in the opposite of y, and opposite of x, let's look what happens here. We still have opposite of y, x squared plus 2. We still have negative 5x cubed. And many people will declare, okay, it doesn't look the same. 5 went to negative 5, y went to negative y, or opposite of y, not the same. But you would be wrong. Let's look at this a little further. We know from previous algebra skills that as long as if you want to multiply something, you do it to both sides. So if I multiply by negative 1, I'm multiplying both sides by negative 1. Left-hand side, y. Right-hand side, I'm going to leave the x squared plus 2. But by multiplying by negative 1, I now have 5x cubed. And lo and behold, it is the original. So this, for many students, is a surprising yes. Let's try one last one. Let's try y equals 5x cubed. So x-axis, plug in opposite y. Not the same, so this is a no. Y-axis, plug in opposite of x. Simplification, not the same, so this is a no as well. And then origin. Opposite of y, opposite of x. And again, cubing a negative 1 is a negative 1. That's why there's a negative here. If I divide both sides by negative 1, or multiply by negative 1 for that matter, we indeed get back to the original. So once again, this is surprising for many